I'm Anil Kumar. Welcome to my series on providing solutions to IIT JEE test questions. In this video, we'll consider the test questions from IIT JEE 2018. We'll solve all of them and I hope you'll benefit from the solution. One of the questions here is, for a non-zero complex number z, let argument z denote the principal argument with argument z between minus pi to plus pi, where plus pi is included. Then, which of the following statements are false? So sometimes they will ask for true, sometimes false. So it is very important to figure out and remember while solving that it is, in this case, false, right? Not true. Okay, so there are four conditions here. The very first one is argument minus 1 minus I equals to pi by 4. So the vector given to us is minus 1 minus I. Right. So the vector given to us is minus 1 minus I. And they are saying argument is pi by 4. Well, that definitely is wrong. Since when we say minus 1, that means, and minus I, that really means that you are somewhere, minus 1 is fixed. So this is somewhere here on this line, correct? So you are somewhere here. So definitely not pi by 4. Pi by 4 will mean what? Pi by 4 is right there, correct? So this cannot be pi by 4. So this statement is false. Since it is false, we are going to circle this. That is what is required, correct? The second question here is, the function f, where r is between minus pi to pi, defined by f of t equals to argument minus 1 plus it, where I is square root of minus 1, right? So complex number. So we are talking about a polar plane, right? Now, for all t belonging to R is continuous at all points of R. So here we have to check continuity, right? So we are now talking about the complex number minus 1 plus it. Now, as we said, minus 1 plus it means again we could be in quadrant 2 or in quadrant 3. This is minus 1 for us, right? So along this line. So it could be anywhere. Now if you see, then in the one half of this, which is in this half, the vector is going to be continuous, right? So what is going to be the argument in this particular half, right? So we are saying the argument f of t, let's write down. F of t is equal to argument of minus 1 plus it. So we could consider different cases. One, when t is between, because this is from minus pi to pi, so when t is greater than 0, right? So we can take when t is positive. So if t is positive, let me write here, if t is, there's less space here, so if t is greater than 0, in that case, what is the argument? Well, we could do something like this. So for our vector, this is going to be the position and the angle. Let us say the acute angle here is theta. Now this angle theta will be represented as pi minus theta. That is the argument. Is it okay? Now when t is less than 0, right? So we'll restrict ourselves to the domain given to us. What I'm trying to say is t is less than 0, but t is greater than minus pi. So when I say t is greater than 0, that means it is less than equal to pi, correct? Okay. So in that particular interval, the position will be somewhere here, okay? Now in this case, if I am looking into the angle theta, then what is the principal angle? Well, the principal angle in this case is going to be from here, right? Minus pi plus theta, right? So that becomes the argument when we are looking into the interval where t is between minus pi to 0. And during these two intervals, it is continuous, no problems in that. Now what we need to actually figure out, what happens at t equals to 0. That is what we need to figure out. So what we really need to figure out is what happens at t equals to 0. Is it continuous there? That is what it is. So what we should figure out is what happens when we are approaching 0 from the positive side. Right? So when we are approaching from the positive side, then what happens? And what happens when we are approaching 0 from the negative side? That means this side. Well, from the positive side, we already have an expression, which is this one for us. And from the negative side, we can fill up from here. And clearly you can see that if t is approaching 0 from the positive side, we'll end up with the value of pi. And here we'll end up with the value of minus pi. Now that is not equal, right? So the argument is not equal. Perfect. So we see that the argument, when we approach this from both the sides, is not equal. So we say is discontinuous. Is that clear? Since they are not equal, correct? Okay. So what was the question saying? Is continuous at all. So this is also false. It is discontinuous, right? So we'll say this is false. Since we are looking for false, we'll circle this also. Clear? Now let's look into part C and D on a fresh page. Okay. So we have already figured out that both are false. And since they are false, we'll circle them, right? We want everything false. Now what is C? For any two non-zero complex number z1 and z2, the argument z1 over z2 minus argument z1 plus argument z2 is an integer multiple of 2 pi. Well, let's figure this out. Well, this comes from the straight formula. When we say argument z1 over z2, in that case, it really means argument z1 minus argument z2 plus 2n pi, right? So we have to adjust the angle, right? So that is the meaning of argument z1 over z2. Now if I substitute this value, then what happens? Let's see. So the expression which is given to us is this, which is argument z1 over z2 minus argument, z1 plus argument z2, right? So we'll substitute this value here. So we have this as equal to the first term is argument z1 minus argument z2 plus 2n pi. Then we have minus argument z1 plus argument z2 is equal to what? So from here, z1 cancel, this also cancels. So we are left with 2n pi. Okay. So we say for any two non-zero complex numbers z1 and z2, this particular thing is an integer multiple of 2 pi. That is true. Since it is true, we are not going to circle this one, right? Okay, the last one here is for any three given distinct complex numbers z1, z2 and z3, the locus of the point satisfying this condition lies on a straight line. Well, let's look into this on a fresh page. So now we are given four complex numbers. So we have z, z1, z2 and z3, right? So, and we are given a condition here. They lie on a straight line. Well, when there are four vectors, it gives you a hint that we are talking about a quadrilateral, right? So it is a thought process. When you read a question, that's what you get, right? So any three distinct complex number the locus of the point satisfying the condition z minus z1 over z minus z3, and this is z2 minus z3, and this is z2 minus z1, right? So what we can do here is we can think about this as argument of z minus z1 over z minus z3 divided by z2 minus z3 over z2 minus z1. So that's as good as writing like argument of a over b, right? So when you have argument of a over b, and here they are saying it is pi, that means that the angles formed by these, their sum is pi. Correct? That's what it means, right? So that suggests you about cyclic quadrilateral, right? So it gives you an idea that it is cyclic quadrilateral. Cyclic quadrilateral is one where all the points are on the circle, right? All the points are on the circle, correct? So in the given scenario, if you think like this, z minus z1, so that will be z minus z1, z minus z1. Z minus z3 will be like this, z3, correct? Then you say, so that means this is the angle theta. This is one angle theta, right? The other term which is in the denominator is z2 minus z3. So z2 minus z3 means, let's say this is z2 now. And then z2 minus z1 will be this, z2 minus z1. So what we are given here is that this angle is pi. We are given this angle is pi. That means this is pi minus theta, correct? Now clearly, if it is a cyclic quadrilateral, because the sum of opposite angles is pi, right? So what we see here is it's a cyclic quadrilateral. So all points are on a circle, so not a straight line. So they are on a circle. Therefore, this statement is also false. And we'll circle this also. So we already circled A and B, right, earlier. This one was true. So that is how we are going to solve this particular question. So I hope it helps. So what we understand from here that this is a good question which really tests your basic understanding of the whole topic, complex numbers. And there are some difficulties. At times this could be a difficult question for some of you. However, most of it is based on the common understanding. So my emphasis is that you should go with very strong foundation for IIT JEE. That should definitely help, right? Now also look into the other questions and their solutions. Feel free to write a comment, share your views, and share my videos with your friends. Thanks for watching and all the best. Here is a question on vectors from last year's test paper, 2018 that is. We'll see how to solve this particular question. The question here is, let P1 be 2x plus y minus z equals to 3, P2 x plus 2y plus z equals to 2, be two planes. Then, which of the following statements is true? So there are four statements. A. The line of intersection of P1 and P2 has direction ratios of 1, 2, minus 1. B. The line 3x minus 4 over 9 equals to 1 minus 3y over 9 equals to z over 3 is perpendicular to the line of intersection of P1 and P2. The acute angle between P1 and P2 is 60 degrees. And D is, if P3 is a plane passing through the point 4, 2, minus 2 and perpendicular to line of intersection of P1 and P2, then the distance of the point 2, 1, 1 from the plane P3 is 2 over square root 3. So on this particular question, you will notice that we're actually kind of touching upon most of the concepts learned under the heading of vectors, correct? So it is not really a very difficult question, but definitely it requires good foundation. The key here is based on the line of intersection of these two planes, right? So let's try to understand that. And then one by one, we are going to answer these questions. So two intersection planes, they intersect. Then what is and how is their direction related, right? So how is their direction ratio related? Well, in case of two planes intersection, if n1 is the normal of the first plane and n2 is normal of the second plane, then that cross product gives you the direction of intersection. So this is the key idea, right? So we will see. We'll actually find this cross product and then check whether it matches with 1, 2, minus 1 or not. Part B is the line is perpendicular. So when you are given a line in this form, it is a good idea to rewrite this line, correct? So once you rewrite this line, you will know from the denominator what is the direction of the line, and comparing what you got here, you can answer this question. So that's not difficult either, right? C. The acute angle between P1 and P2 is 60 degrees. So we have to basically find the acute angle, correct? So that could be between two normals, right? So the acute angle, we can say cos theta is equal to, we can figure out whether it is 60 or not, right? So n1 dot n2 divided by the magnitude of n1 and n2 will give us the angle. And D is, if P3 is a plane passing through the point 4, 2, minus 2 and perpendicular to the line of intersection of this, then the distance of this point from the plane P3 is what? Now as soon as we say perpendicular to the line of intersection, that means its normal, let's call this as N3, will be D1. So once you know that, you could write your equation as AX plus BY plus CZ plus D equals to 0. The given point will give you the actual equation, and then the distance could be calculated very easily, right? So you know the distance formula, that should give you the answer. Is that okay? So that way, if you realize this question is relatively simpler, right? So what I'm trying to concentrate here on is, when you're preparing for IIT, don't rush. Just as I'm speaking to you very slowly and lightly, you have to read that chapter in this fashion. Grasp as you move along, right? So once you get the whole chapter in, then in an examination like this, you will be in a position to solve such a question easily. Otherwise, it may really become very difficult. Perfect? So I think with that advice, let's move forward and answer these questions one by one. So the very first one here is, we need to find the line of intersection. Okay. So here I've rewritten all these questions. So plane 1, let's write the normal for plane 1, which is what? 2, 1 minus 1, correct? And for plane 2, normal is 1, 2 and 1, correct? So now what we need to find? We need to find n1 cross n2. That is what we need to find, okay? So let's use the determinant to find the value. IJK 2, 1 minus 1, 1, 2, 1. Right. So that gives you what value? You can actually pause the video, answer this question, then look into my suggestions, right? So normally we write these with cap and, we say I cap. So I'll just say the unit vector I, right? So 1 minus of this becomes plus 2, right? Minus j cap. Okay. So 2 times, okay, and this is minus, so that becomes again plus k. And 2 times 2, 4 minus 1. So that gives you 3i minus 3j plus 3k, correct? So 3 you could just factor it out. We are looking for direction vector. So we get, so it is plus j, right? Minus j and plus k, correct? So we just factored out 3. So basically the direction ratios, what we get? So we get the direction ratios which are what? 1, minus 1 and 1, not this. So this statement is false. So this is false. In our answer, we are looking for true answers, right? So that is not one of our answers. However, this is a very important conclusion, 1 minus 1, 1, which we are going to use in rest of the questions, correct? So let's move on to part B. So here we are given a line. Let me write down the direction vector here before we forget. Direction vector is 1 minus 1, 1. Correct. So that is what we got when we did n1 cross n2. Okay. Now here we have a line which is 3x minus 4 over 9 equals to 1 minus 3y over 9 equals to z over 3. How do you get the direction of this line? Well, we should write it in standard form. That means x minus x1 over denominator, right? So what we get here is that we have to divide by 3. So we get this as x minus 4 over 3 over 9 divided by 3, which is 3, right? Now in this case, we have to write this first, right? Okay, so that's tricky. Let me rewrite this once again. So we'll write this as 3x minus 4 over 9 and we'll rearrange this. Minus 3y plus 1 over 9 equals to z over 3, correct? Now, we'll divide by minus 3 all these terms, right? Okay, so when I divide by minus 3 in the numerator, I get 1 over 3 with the negative sign here, and in the denominator, when I divide by minus 3, I get minus 3. Here we already have z equals to z over 3. So what is the direction of this line? So let's call this line as L1, and the direction vector D here is what? So here direction vector you can say is 3 minus 3, this is 3, 3, or you could say 1 minus 1 and 1, right? So that is the direction. We want it to be perpendicular. No, this is parallel. So this is parallel. Is that clear? Not perpendicular. So we got the solution for the second one also, and that is also false. Is it clear? Now let's look into part C. So here the angle cos theta will be equal to the dot product of n1 and n2 divided by their magnitudes. Okay, so the vectors are 2, 1, minus 1, dot 1, 2, 1 over square root of 2 square plus 1 square plus minus 1 square times square root of 1 square plus 2 square plus 1 square. So that gives you, we get 2 plus 2 and that minus 1 divided by 4 plus 1 5 plus 1 6. Right. So what we get here? 3 over 6. So that is cos theta. So cos theta is basically half. Cos theta is half. That means theta is what? Look into your triangle, right? So 1, 2, square root 3 triangle. That is 60 degrees. So it is indeed theta is 60 degrees. So this statement is true. So we have to mark the correct ones. We'll mark C, right? So that is correct answer, right? Now let's look into part D. Part D is, if P3 is a plane passing through the point and perpendicular to the line of intersection of P1 and P2, then the distance of this point from the plane is given to you. Okay. So we found that the direction of intersection, which was N1 cross N2, we found this to be 1 minus 1, 1, correct? 1. Okay. So we'll take this direction. Now that is now the normal for the third plane, right? So we'll find the equation of P3. Since we know that is the normal, the equation has to be A is 1. So in general, it is AX plus BY plus CZ plus D equals to 0, right? Now since we know that the normal is this, we can write this as X minus Y plus Z plus D equals to 0. Now we are given that there is a point on it, and the point given to us is 4, 2, minus 2, correct? So we have a point, let's say call it A, which is 4, 2, minus 2. So we'll substitute this here to find the value of D. So we get 4 minus 2, this is also minus now, plus D equals to 0. So that gives you 0, so that gives you D equals to 0. Okay. Since D is 0, so we get the equation of the plane now, which is what? D is 0, so that is the equation. X minus Y plus Z equals to 0. So that becomes the equation of our plane. Okay, now, then the distance from this point to the plane is what, right? So we have just to find the distance from a given point to the plane. So use the formula. It is a straight formula based question. So the absolute value of distance will be what? Will be all this, okay, from a point, we are saying the point is 2, 1, 1. Okay, so we'll just write AX plus BY all this, which is 2 minus 1 plus 1 over square root of this. Let me write the formula first. Okay, so I wrote it earlier, so we'll write this as, in general, it'd be, sorry, so absolute value of AX plus BY plus CZ1, so we are substituting the point, right, over square root of A square plus B square plus C square. That is the distance formula, correct? So we have written this since that is the equation, right? And the point given is 2, 1, 1. So we are writing these values, and the normal is right here. Let me highlight the normal, which is also the coefficient, as you know. Okay, so it is 1 square plus minus 1 square plus 1 square, right? That is the distance. So that is 2 over square root of 1 plus 1 plus 1, which is 3. So that is correct. We are given P3 distance as 2 square root 3. This is correct. So this is also true. Perfect. So in our answer, we got the last two as correct options. So getting back to where we started, right? So let's look into the question once again. So relatively, it was not difficult. However, we need to understand each and every concept of a topic, right? So this time it was vectors. So we found that last two statements were correct. So they will be circled since we are looking for true answers. I hope you understand and appreciate how to tackle these questions and how to prepare for them, correct? So I will really advise you not to rush for very difficult questions, as I've seen people practicing. A lot of cross products, right? They are not required. What is really required is the concept. So I'll provide you some links. You can go through those links and understand all the concepts if something is not very clear to you, and prepare for your next test. Hope that helps. Feel free. Now this question relates to a triangle. Now anybody who is working on triangles, sine law, cosine law, circumscribing and inscribing circles will be interested in this question. Let's look into it, and let us also appreciate how everything has been merged into a beautiful question. The question here is, in a triangle PQR, let angle PQR equals to 30 degrees, and the sides PQ and QR have length of 10 square root 3 and 10 respectively. Then, which of the following statements is or are true? So there are 4 statements. We have to figure out which ones are true. A. Angle QPR equals to 45 degrees. B. The area of the triangle PQR is 25 square root 3 and the angle QRP equals to 120 degrees. C. The radius of the incircle of the triangle PQR is 10 square root 3 minus 15. And D is the area of circumcircle of the triangle PQR is 100 pi. So from this you get an idea that you should really thoroughly understand the whole topic to answer a question when it is about IIT JEE. Now this is relatively a simple question. Let us see how to answer this. So we'll first make a sketch. So we have a triangle PQR here. So we are given that the triangle PQR has an angle of PQR as 30 degrees. So this angle is 30 degrees. And we are given the sides PQ and QR are 10 square root 3 and 10 respectively. So drawing is not to the scale for sure. Yes. We need to figure out what is the angle QPR. So we need to find what this angle is. Now whenever you are given 2 sides and an angle, so we are given side, angle, side, that means cosine law. Okay. So using cosine law, let us figure out what is PR equals to. Correct? So let's find what PR is equal to. So we can say PR square, let me write down here. So we'll say PR square should be equal to QP square plus this square minus 2AB cos theta, right? So we'll write 10 square root 3 whole square plus 10 square minus 2 times 10 square root 3 times 10 times cos of 30 degrees. So that is what PR square is. So once we know PR, we can use sine law and find the angle, correct? Now cos of 30, so cos of 30, let's make our special triangle. So 30 degrees, 60 degrees, I mean this is 60 degrees for me, this is 30 degrees, 1, 2 square root 3. So cos of 30 degrees is square root 3 over 2. Correct? Okay. So we'll substitute that value here. So PR square equals 2. We got 100 times 3, that is 300, plus another 100 minus. So we get 100 times 2. So we get 200. And then we have square root 3. And then cos of 30 is square root 3 over 2. Okay. So this can be simplified. Let's write like this. So PR square equals to 300 plus 100 minus that 2 goes and we get 300 here, right? So we get 300 here. So that gives you 100. So PR square is 100. So that gives you that PR is basically equal to square root of 100, which is 10. So this side is also 10. Well, that makes things simpler. That means it is an isosceles triangle, right? So the sides opposite should be same. So this angle is 30 degrees. And so angle QPR is 45 degrees is false. So that is definitely not the right answer. Okay, so let's move on and then see what is the area of the triangle PQR, and also we have to find the angle QRP. Well, angle QRP we can still find. So let me do that part. Angle QRP will be what? 180 minus 60, right? So this is equals to 180 degrees minus 30 minus 30, which is 120 degrees. So this part is correct. This part is correct. So let's move on to the next page. We'll copy the diagram. We know now this is 10, that is 120, and then we'll find the area of this triangle. Okay. So now let's do part B. Let me just sketch the triangle once again here. Right. So we got the triangle. We are saying this is 10 square root 3. This we found also as 10. This is 10. This is 30 degrees. Okay. Now the sides are P, Q and R. Perfect. And we found that this is correct, right? This is correct. This side is 30 since it is an isosceles triangle, and that angle has to be 120. Drawing is not to the scale. Perfect. Now let's see how to find area of this triangle. Now area we could find, we can drop a perpendicular from here, right? In that case, let's say this is D. So we know PD will be equals to 10 square root 3 sine of 30 degrees, correct? So sine of 30 degrees will be half, so it is 10 square root 3 by 2, so which is 5 square root 3, correct? So we know this side is 5 square root 3. So area of triangle PQR is half base, which is QR, times PD, which we'll write as half of 10 times 5 square root 3. Okay, so that gives us 25 square root 3. So that's true. So that 25 square root 3 is correct. So it matches. So this is perfectly fine. So we'll circle this, right? Because we are looking for true answers. Correct? Now let's move on to the next question. In the triangle PQR, the same question, we need to find the radius of the incircle of the triangle PQR, and then we have to match, right? So basically what we have is this triangle, which is not drawn to the scale. We are looking for the radius of this circle, R, right? Now, how is radius related? We actually found the area, right? We found the area just now as, I think it was 25 square root 3, right? So it was 10 times 10 square root 3, and this side was 5 square root 3, right? Correct. So half of this, half base into height, 25 square root 3 was our area, correct. Now we need to find the radius of the incircle, and is it 10 square root 3 minus 15? That is what we need to figure out. Now if you remember, the radius is related with the perimeter of the particular triangle, correct? So the radius is basically equal to area of triangle this is incircle radius R, which we're talking about, divided by semi-perimeter. I'll attach this file which gives you the derivation of the formula at the end of the video. So basically the radius is area of the triangle. Let me write area of the triangle and semi-periperiod S in bold so that you remember this formula, right? So we're directly going to apply this formula and get the result. We know area is given to us as this, and what is semi-perimeter? We know all the three sides. This was also 10. So we'll do 10 plus 10 plus 10 square root 3 divide by 2, right? So that's what we have, and that is 20 plus 10 square root 3 divide by 2. So S is 10 plus 5 square root 3, right? And therefore, we can now find R using the formula. So R is equals to the area of the triangle divided by S, which is 25 square root 3 over this value. 10 plus 5 square root 3. Okay, so we could simplify this, dividing all by 5. We get 5 square root 3 divided by 2 plus square root 3. And what we need to match with is 10 square root 3 minus 15. So we need to rationalize this, correct? So let's rationalize. So we'll multiply by 2 minus square root 3 over 2 minus square root 3, correct? So let's see what do we get now. So what we get here is R equals to, when you multiply, you get 5 times 2, 10 square root 3 minus 5 times 3, 15. Okay. And the denominator will be a square minus b square, which is 4 minus 3, which is 1. So that's what you get. So you get 10 square root 3 minus 15. That is correct. So we got the same as this. So this part is correct, right? So C is also correct. Perfect. Now let's move on and do part D. Now in the same triangle PQR, we need to find area of the circumcircle of the triangle PQR, and we have to match it with 100 pi. So basically now we are looking into the area of the circle, and we have our triangle inside, right? So we have a triangle which is PQR, kind of like this. So in this triangle, we know the sides are 10 square root 3, 10 and 10. So first thing which we need to find is the radius, right, of the circumcenter. So let's say that radius, let's say this is O. So OP, which we need to find, right? Now how do you relate this radius with the sides of a triangle? So if you remember, we have this formula that twice the radius is basically equals to any side over sine of that angle, right? Sine of that angle. So this is a very important formula which can be applied here. I'll provide you the derivation of this formula so that you could apply it and understand how. So basically when we are working on a topic, we have to relate it with so many other things and remember the relations to solve. Otherwise, it becomes slightly time consuming to derive and then do the needful, right? Okay, so we'll apply this formula to find, we're calling that to be the radius OP, right? So in our case, we know that we can use any angle. We know this was 30. That is a better side to use. We'll use any side we can use, 30 and 30, correct? So we can use these sides. So Q. So we can say twice this radius OP in our case, right, will be equal to the side opposite to Q is 10. So 10 over sine 30. Is that okay? Sine 30. So we get OP as equals to half of 10 over, what is sine 30? Sine 30 is half, right? So in our triangle, this, as you know, this is 1, 2, and that angle is 30 degrees, correct? So sine 30 is half. right? So we get OP as equal to 10 because this 2 cancels with this half. So we get OP as 10. Now if OP is 10, then the area of circumcircle will be pi OP square, correct? Which is pi times 10 square, which is indeed 100 pi. Is it okay? So that answer is also correct. We have to circle the correct answers. So that is how we are going to solve this question. So you must have observed here that this question involves relating the triangle, the circle, cosine law, sine law. So that's the beauty of the question, and I hope it is helpful for all of you. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Also, you can look for the derivation of these formulas at the end of the video, which I'm going to attach with them. I hope that really helps. Thank you, and all the best. Here we are going to describe and derive a formula between in radius and the sides of the triangle. When I say in radius, that means we have a circle inside a triangle, inscribed in a triangle, and in radius is the radius of this circle, which is inscribed, right? So that is the radius which we are talking about. We want to relate this radius with the sides of the triangle, right? So if we have a circle inscribed in a triangle, in that case, all the sides will be tangent to the radius, right? So we have a right triangle right there. Let us say that the triangle is triangle ABC. Then the sides could be referred to as lowercase abc, right? Now, in this particular triangle, as you will see, that if I join the center, let's say the center is O, if I join the center with the vertices, then what do I get? I get 3 different triangles. Right? Now, we can say that the area of the big triangle ABC is basically equal to area of small triangles AOC plus triangle COB plus triangle AOB. Right? So area of all these combined, right? So we have one of these triangles that is like one of the triangles, correct? Then we could have the other triangle right there, and the third triangle. So it is sum of all these 3 triangles. Now area of triangle is half base into height, right? So we could write the area of this triangle is what? Half of this side times height. Area of the other triangle will be half of the other side times height. Now in all the 3 cases, height is what? R, right? That is the height. Right? So we can write down these areas as half of area of triangle AOC will be B times R plus COB will be half times A times R plus the angle triangle AOC, it will be side C times R. So we can take half R common, we get B plus A plus C. Or we can say it is R times A plus B plus C divided by 2. So that becomes the area of triangle A. Right? Now many times we use S as sum of the sides divided by 2, right? So I could also write this as area is R times S. Perfect. So that is a very good relation to remember. So if I make this triangle here, to remember the relation between them, in that case area is R times S. So what is R? The inscribed circle radius. Well, the inscribed circle radius R is equals to the ratio of area over S, right? So these are two very important formulas which you should remember. So when we say circumradius, we basically mean to say that we are trying to find the radius of a circle in which we could inscribe a triangle, or circle is circumscribed on a triangle. So let us assume that this is a triangle, and here we have a circle of radius, let's say capital R, which circumscribes. We need to find a relation of this radius capital R with a relation of radius capital R with the sides of the triangle. Now for that, let's do a bit of construction here. Let us assume that we have center O here. So we'll join center O with the two vertices of a triangle. Let the triangle be ABC. So side opposite to A will refer to as lowercase a, right? Now let us say that I drop a perpendicular from the center to BC. Now since these are the two radii of a circle, they are same, correct? And therefore we'll have the same angles also here, correct? And we have 90 degrees. So these are common side. So these are actually congruent triangles, correct? So in that case, the length here, let's call this point as a D, right? So in that case, we know BD will be equals to DC, and both will be equal to half of A, correct? Now, let us say the angle here is theta. Let me use a different color here. If this angle is theta, the total angle at the center will be 2 theta. So the smaller angle will be also theta, correct? These two will also be theta each, because the center angle will be twice that angle, right? So now we have a right triangle. So if you look into the triangle, which is BDO, in this particular triangle, what is sine theta equals to? Well, sine theta is opposite side over hypotenuse. The opposite side is BD and the hypotenuse is OB. So from here you can see that sine theta is basically equal to B to D is half times A, and OB is our capital R, the circumradius, right? So from here we get a relation between circumradius and the side length, correct? So if I cross multiply, I get radius is equal to A by 2 sine theta, correct? So that becomes a relation between the radius, the side, and the angle opposite, like a sine law, right? So if you want to relate it to sine law situation, you could actually write this formula as 2r equals to A over sine A, because this angle theta is actually the angle A, right? So that is how we can actually relate circumradius with angles and sides of a triangle. That's a very important formula. Now let's also derive another formula where we will relate the side lengths with the circumradius. So for that, I have a triangle here, and we'll take this triangle as let's say triangle ABC, any triangle which is circumscribed with this particular circle. Now let's join point B with the center of the circle, right? Let's say this is the circle center, then that becomes the diameter, right? Let's call this point as point D. So in that case, this length B2 circumcenter will put O, right? We'll put D here. So in that case, what we have here is OD is the diameter, right? Half of the diameter. Because B to D is the diameter, I wrote OD, half of the diameter. So which is the radius R for us? We'll call this as radius R, the circumradius. Now we need to find this radius with respect to sides ABC of a triangle. Now in this particular triangle, let me drop a perpendicular from B to base AC. Let this be the perpendicular, this side be, this point be E. And let us say that, so that becomes the perpendicular. Now, if I join points A and D, in that case, that is a semicircle. So in semicircle, we'll have a right triangle. Right? So that becomes a right triangle. Perfect. Now we also see that these two angles, they should be equal. Reason being that both these angles are on the same arc, arc AB, right? So this angle, angle BDA and angle BCA, both are on this arc. So we have that angle BDA is equal to angle BCE. And that is 90 degrees. So we know angle BAD is equal to angle BEC. Both of them are 90 degrees. So from this, we can say that the triangle BAD is similar to the triangle BEC, correct? AA property, right? So from AA property. Is that clear? So these two triangles are similar. Now once this big triangle and that small triangle, we show that they are similar, in that case, we can now say that the sides are in fixed ratio, right? So what we have here is B to D over B to A is basically equal to B to C over B to E, right? Now, B to C is side opposite to A. I'll call this as lowercase a, right? So this side I'll call as A, and this I'll call as height H. Is it okay? So we could write B to C as A, B to E as H. Now BD. B to D is 2 times R. And B to A, this side is opposite C, so we'll name this as C. Is it okay? So this will be side C. So we just named them as per our triangle sides. Now, this height H, we can relate with the area of the triangle, correct? So for the triangle ABC, what is the area of triangle ABC? The area A is half of base AC, which is B, times height H. So from here, I can write that height is 2A divided by B is height. Now replacing that height in this formula, what do we get? We get 2R over C equals to A over, instead of height, I am writing twice area over B. Correct? Now we can actually correlate radius with the area of a triangle and the sides of the triangle. So if I cross multiply, take C on this side, that B comes on the top, we get ABC in the numerator and this 2 in the denominator. So we can write R is equals to ABC over 4A. Is that clear? So we cross multiply to isolate R. Does it make sense to you? So R is ABC divided by 4A. So if we know the area of the triangle, in that case we can find the value of circumcenter radius using this formula. Correct? So that is a very good way of relating them. So that's the second formula which we should remember, which is radius R is equals to product of all the three sides divided by 4 times the area. So these are two very important formulas to find the circumradius when we are solving questions related to triangles and circles. So I hope the derivation is absolutely clear and it's easy to remember that the radius, twice the radius is A over sine A. That is a sine law kind of portion, right? Twice the radius. So if you know angle C, it could be C over sine C. In this case, radius is equal to, the circumradius is equal to product of all the three sides divided by 4 times the area. Perfect. So that is how we relate them. I hope you find them useful. We'll take a few multiple choice questions based on this. Feel free to share my videos with your friends, and if you like and subscribe to them, that'll be great. Thanks for watching and all the best.